UniFi network controller can show you the complete network topology. Yes, sometimes it doesn't reflect the updated information. Sometimes it's buggy, but to be fair, at least for me, most of the time it works. So when it works, it's a very helpful tool for you to quickly understand how a given device is connected to your network. You may wonder how this tree structure is constructed, how it works. So in this video, let's talk about it. The network topology is built mainly based on LLDP information. So in the lower part of the screen, I show you the Wikipedia article about LLDP. It's short for Link Layer Discovery Protocol. In fact, the old name is easier to understand. It was called Station and MAC Connectivity Discovery. So basically, it's to discover station and it's related to MAC address. So it's a vendor neutral link layer protocol. Network devices can use it to advertise their identity, capability, and neighbors. LLDP collect a lot of information. In the right side, I can show you an example LLDP packet. Under the LLDP, there are multiple sections. Each section is called a TLV. In the Wikipedia article, you can also see the explanation. It stands for type length value. Each TLV is for a unique piece of information. For example, the mandatory part information, chassis information, and the TTL information. And then there are a lot of optional information about this particular device. If you check the Ethernet section, you can see the destination is LLDP multicast. The MAC address is like this. In the Wikipedia article, it mentioned 3 candidates for the hard-coded destination MAC address. By the way, what I'm showing you here, each packet is called a LLDP DU. It's a data unit for LLDP. It's a sequence of TLV structures. In this video, I'm going to SSH into multiple UniFi devices, a gateway, multiple switches, a CloudKey, 2 access points, and a UniFi Protect camera. By using all the different sorts of UniFi devices, you will understand for different devices how the LLDP information is collected. We will also talk about some special cases. For example, what if an access point is meshed? What if you have a Bluetooth connected UniFi Protect sensor? A lot of details to cover. Let's get started. Since the network topology is a tree, let's start from scratch. Let's construct the whole tree from the root, the gateway. So in the lower part of the screen, I have 2 terminal sessions. For each parent-child relationship in the tree, I'm going to show you the LLDP information in the 2 separate sessions. UX3 Pro is a gateway instead of a switch, so I assume it simply supports LLDP using the popular service LLDPD. To confirm that, let me run ps command, try to find the LLDPD processes. Yep, you see the LLDPD is running, right? Because of these findings, I can confidently run LLDP CLI to launch the command line interface. Okay, now I can show the information about the UX3 Pro itself. Show chassis. Okay, you can see the UX3 Pro itself information. For example, I can also say show interfaces. For each interface, it will give me more detailed breakdown. And let's see what type of neighbor information it has already gathered. Show neighbors. Okay, it's showing 2 neighbors. So one connected to the one part. By the way, I'm running the lab environment behind my main router. So that's why here you can see from the one part, it shows the UniFi switch name, which is not part of the lab environment. It's part of my production environment. And then from the LAN part, you can see, okay, the first switch is the USW Pro 24. See the topology? yes, the first level switch is the USW Pro 24, right? It shows the device information about the switch. By the way, where this information comes from is from the LLDP information for the switch. We will find out later when we look into the switch. So for now, yes, we see the device itself's information. We see the remote neighbor information, right? To see the LLDP network packet, let me capture network traffic. So let me first capture the LAN part information. Give it some time. The first captured packet is from the USW Pro 24 switch. Let's check it later. And then the second packet is about the UXG Pro. If we check the information, see the LLDP section, it has all the device information as we discussed earlier. Okay, so we are good from the LAN perspective. Before we move on, there's one last thing I want to mention regarding UXG Pro. So you may know normally you run UXG Pro, connect to your ISP with your WAN part. In the past, Ubiquiti sent out the LLDP data unit even to the WAN part, which means your own gateway information is sent to your ISP. Ubiquiti didn't have a way to disable it, but you can see from the captured packet, it does include a lot of information which is not supposed to be exposed to outside world, right? But now, do we still have the problem? So let me exit the LLDP CLI. Let me show you a LLDP configuration file. It's in the run folder, and the name is lldpd.config. It says for port 0 and port 2, the LLDP is receive only, which means for these two parts, the UXG Pro will not send out the LLDP information. What are these two parts? They happen to be the two WAN parts, which means at least now, at least for UXG Pro, the system doesn't send out the LLDP information to the WAN part, which is good news, right? And to furtherly confirm that's the case, for the Wireshark, let me capture the WAN part information instead of a LAN part. Okay, give it some time. I already gave it enough time, more than 30 seconds, but the only LLDP DU I received was from the aggregation switch. As I mentioned, is outside of this lab environment. It's connected to the WAN part of the gateway. From the WAN part, I do not see the LLDP information from the UXG Pro. If we run the LLDP CLI from the UXG Pro again, and we run command update, this command will trigger the LLDP DU packet to be sent out. So let me run it. But in the right side, you don't see the UXG Pro's information because the system disabled the WAN parts to send out LLDP information. Now let's move on to the first level switch, the USW Pro 24. Let's examine the parent-child relationship between this Pro 24 switch and the Enterprise 8 PoE switch. So in the left side, let me SSH to the parent. In the right side, SSH into the child. Even though one is Pro switch, the other one is Enterprise switch, because they were released in different years. The old one still has the traditional edge switch CLI, and the Enterprise switch has a newer type of CLI, but they are pretty similar. So let me go to the CLI to both parent and child. Let me show the LLDP remote devices for both switches. Show LLDP remote device all. Okay, see from the Pro 24 switch perspective, it's showing two remote devices. For the port 25, it's connected to the Enterprise 8-port switch, and for the 26 part, it's connected to UXG Pro, which is its parent. Okay, then in the right side, let me run command show LLDP neighbors. As I mentioned, they have different CLI, so that's why the commands are different. Interestingly, for the Enterprise 8 PoE switch, it's showing 4 neighbors. For U6 Pro, it's a UniFi access point, and then it shows 2 small switches, the Flex Mini and the 2.5 gigabit Flex switch. Then the fourth node is the USW Pro 24, which is its parent. So you can see from the parent, you can see the child. From the child, you can see its parent, right? So this is how the system can construct the three-node parent and the child relationship. At this point, you may already realize the LLDP information will not be forwarded to the upper level switch. From the left side, you only see the enterprise switch. You do not see, let's say, this access point and these 2 small switches. You don't see them. Only their direct parent can see them. That's very important for LLDP. So let me show you the Wikipedia article about LLDP again. See this sentence. If the destination MAC address is one of these 3 hard-coded ones, the switch will not forward the packet. Because of this special treatment, the system will not forward all the messy LLDP data units from all its nodes. Only its direct parent will receive them because they are directly connected, right? Okay, that's one thing I want to stress. So now we see the remote devices or neighbors information from each device itself. And to see it in action in the Wireshark, let me capture the LLDP packets. From the Wireshark perspective, this machine has 3 Ethernet interfaces. For this particular one, EN0 is connected to this Pro 24 switch. So that's why we can see from this pair of parent-child perspective, what are the LLDP packets started. 2 packets are captured already. So the first one is the LLDP DU from the UXG Pro, the root of the tree. And then the second one is from the USW Pro 24 itself, the child node. See later, after 30 seconds, we received another pair of packets. So for every 30 seconds, the device will send out the LLDP multicast with the information for itself. Each device can use the LLDP client to maintain the neighbor information. Let me capture packet for another interface. So this one is connected to the enterprise switch. By capturing packet for this part, I will understand the packet for this particular section. Started. So the first packet is from the enterprise switch itself. Then later, we received the packet from the Flex Mini, then the U6 Pro, then another small switch, the 2.5 gigabit one. So that's how this particular enterprise switch can collect all the LLDP information from its parent and its children. You may already notice we are missing several devices. From the Pro 24 switch perspective, it's missing this particular UniFi device, which is the CloudKey. And from the enterprise switch perspective, we are missing this UniFi Protect camera. Even though these 2 devices, they are both UniFi devices, we do not receive the LLDP information from them. Let's SSH into these 2 devices to understand what happened. Let me SSH into the CloudKey. Okay, see the right side network controller. The CloudKey is connected to the 24-port Pro switch, right? But the fact that when we use Wireshark to check the packet for this switch, we didn't see the LLDP packet from the CloudKey. That implies the CloudKey doesn't run LLDP-D, the daemon. That's why it didn't send out the LLDP data unit, but we can confirm in the SSH. Okay, you can see there's no running process has the name LLDP-D. However, it may run LLDP client, the CLI interface. Let me try it. No, we don't have this tool installed. Let me do the final try. Let me see whether there's anything for LLDP if we run network control. Yeah, we do see something. Here it simply lists the device this CloudKey discovered, which is the USW Pro 24 switch. It makes sense because from the topology you can see the only LLDP data unit this CloudKey is supposed to receive is from the USW Pro 24, right? So it makes total sense here. Okay, the conclusion is the CloudKey doesn't run daemon for LLDP, but it does have the ability to discover neighbors. To put it the other way, when the system draws this topology, it can either use the discovered neighbor information from the CloudKey to construct this parent-child relationship, or it can simply treat this CloudKey as a client, a regular client. It doesn't have to be from Ubiquiti. Just by checking the MAC address table, the switch should be able to find this information as well. We can discuss the details when we look into the UniFi Protect camera. So then in the right side SSH session, let's check the G file flags, the UniFi Protect camera, to see how this part of topology information is constructed or discovered. By the way, it's very tricky to SSH into the UniFi Protect cameras. If you are interested, check my video about how to enable SSH for UniFi cameras. So here I already did the needed steps, so that's why I can SSH into it. Then in similar way, let me try to find out whether we have LLDPD running. Okay, it has different syntax. Let me try it another way. No, we don't have LLDPD. Then what about LLDP client? No, it doesn't exist. Then whether we can use the left side CloudKey way to run network control command. Let's try. No, the command doesn't exist. We are at the dead end. Then the question becomes how the system even draw this topology, how it can even know G file flags is connected to this enterprise switch. My theory is it's based on the MAC address table. Let me explain how you can do it in a manual way. From the two terminal sessions, I already SSH'd into the two UniFi switches. The left one, the first level switch, the Pro 24. The second session into the Enterprise 8-part PoE switch. Then let me go to the CLI command mode. Then in the Pro 24 switch, let me show the MAC address table. Okay, let me leave it there for now. Then in the right side, let me show the similar thing. The command is a little bit different. Show MAC address table. We got another table, right? Then in the right side UniFi network controller, we can see the G file flags camera has this MAC address. It ends with 0D, DE, 8B. In the left side MAC address table, yes, we can find it here. And in the right side, yes, we can find it here. So let's examine these two MAC address table entries. So in the left side, we can see it's connected with the port 25. Why port 25? You can see from the topology, the G file flags is not directly connected to the Pro 24, right? Port 25 is connected with the enterprise switch. Then in the right side MAC address table, you can see it's connected to the port 5 of the enterprise switch, right? So in fact, from the right side network controller, you can confirm, yes, the G file flags is connected to port 5. How the system can draw this type of topology based on these two different MAC address tables is very easy because on one hand, by using LLDP, the system knows this type of parent and child relationship between the two switches, right? And then just by analyzing the MAC address tables from each switch, the system can easily traverse the tree structure and then to find out the G file flags is the direct child of which switch. So as we just did manually, we can easily find out, yes, it's directly connected to the enterprise switch. and it show up in the MAC address table for the 24-port switch simply because it's indirectly connected with this switch. Okay, I hope it's clear about how the system draw the topology for the CloudKey, for the G5 flags, or even for any other wired clients. For example, this Mac Mini, how the system even know this type of topology information by simply checking the MAC address table. Now let's talk about these three switches. The enterprise switch with two children, one is Flex Mini, the other one is Flex 2.5G. Both the children are tiny switches. If I try to SSH into them, the Flex Mini first, connection closed. That means the switch doesn't provide SSH service at all. What about the Flex 2.5G? Yeah, same error. They don't support SSH at all, but it doesn't mean they don't support LLDP. To confirm whether these two switches are sending out LLDP data units, in Wireshark, let's capture the frame for the enterprise switch. We see the LLDP data unit from the Flex 2.5G already. So that confirms, yes, this switch does run LLDP service. And then if we wait more time, yeah, we see another one from the Flex Mini. So that confirms, even though we don't have a way to really go into the system to see the services, we can confirm, just like other UniFi switches, they both support LLDP. Okay, and let's move on to the very last section. It is about interesting UniFi devices access points. The two UniFi access points show up in different ways in the topology for my lab environment. The U6 Pro is wired using Ethernet cable. You can see the blue line is solid, right? But the U6 Lite is connected wirelessly using Wi-Fi mesh. Let's see how they behave differently when it comes to LLDP. Let me SSH into the U6 Pro first. Whether we can see LLDPD process running. Yes, we do. It confirms, yes, this access point, just like UXG Pro, the gateway, it also runs the popular LLDPD process to support LLDP. And we can use LLDP CLI to see its neighbors. You can see it shows the Ethernet 0, the RJ45 part for the access point. What's the neighbor information? You can see it's USW enterprise switch, right? It makes sense. This is the only neighbor the U6 Pro shows. It doesn't show the U6 Lite at all. That's interesting, right? From the right side Wireshark in the captured packet from the enterprise switch perspective, you can also see the U6 Pro, for example here. But you don't see U6 Lite here. The U6 Pro is wired, so it behaves in a normal way. But the U6 Lite is a puzzle. It does show up in the topology, but it seems it doesn't send out the LLDP data unit, so the U6 Pro hasn't discovered it yet. We can try to SSH to the U6 Lite to see what's happening. And just to confirm whether we have LLDPD running, no, we don't. Why is that? The only difference between the U6 Pro and the U6 Lite is the way they are connected to the network. One wirelessly, the other one in a wired way. Because the connection is wireless for U6 Lite, it doesn't make sense it runs LLDPD. Remember, LLDP is for link layer discovery. It works principally with wired Ethernet, not Wi-Fi. So that's why we don't see LLDPD running for the U6 Lite. But it doesn't mean the device itself doesn't know how it's connected to the network. We can easily find out the connection information by running the WPA CLI command. If we try to see the status, by the way, the WPA CLI is to check the information from the Wi-Fi client perspective. So even though U6 Lite it is an access point. It provides Wi-Fi services to its wireless clients. It is also Wi-Fi meshed to the network, so itself is also a Wi-Fi client. So what we are trying to check is the information from client perspective. Here it shows the BSS ID and the SSID. The UniFi system can easily find it out which access point is broadcasting this SSID. It is broadcasted by the U6 Pro. Internally, the system can easily find out this Wi-Fi mesh information to draw this topology. Before ending this video, I still want to mention one exception, which is UniFi Protect sensor. As you can see, I do have a sensor in my network, but in the topology, you don't see it. Why is that? So you may know UniFi Protect sensor is the only UniFi device that only uses Bluetooth to do the network communication. It doesn't support Wi-Fi. It doesn't support wired for sure. Because of the uniqueness, apparently Ubiquiti needs to improve the topology to include the Bluetooth client as well. Even though now there's only one, maybe in the future there will be more Bluetooth only product released from Ubiquiti. So they also need to be incorporated into the topology. So at this moment, if you go to the display option, see for client device, you only see Wi-Fi and wired. I do expect to see Bluetooth in the future. By the way, the sensor itself does know how it is connected, because you can see it's even show up as it's connected to U6 Pro, right? But this relationship is not represented in the topology yet. In the video, we discussed multiple typical scenarios for UniFi network controller to come up with this topology. For UXG Pro and this wired access point, the system is behaving like a regular Linux machine. It runs the LLDP to support LLDP. And then for UniFi switches, the switch itself support LLDP. For CloudKey and UniFi camera, and even for non-UniFi regular wired clients, to draw them in the topology, the system needs to utilize the MAC address table. When it comes to wireless client, even including the meshed access point, the system needs to rely on the Wi-Fi connection information. Okay, by relying on different technologies, the system can come up with this beautiful, elegant, sometimes buggy, sometimes not updated, but many times very useful topology. Okay, thanks for watching.